Just so you know, and this is for the whole class to know, I'm going to set the test for next week, Tuesday. So you have approximately 1 week to get ready for the test.
Okay.
And today I'm going to go through some review to help you to get ready for the test. And then I won't have a class on Thursday because I'm going to expect that you'll use the time to get ready for the test. And I'm
Okay.
also going to put a test review on the Teacher Ease website for you to get some practice. This is going to be a pretty short class because what I'm going to do is not actually calculate any answers. I'm going to leave you to do that on the online quiz, the review quiz. I'm going to kind of give you an idea of what to do, but not actually do it for you. So that's the whole idea of today's class. That's why I don't think it's going to be a long class at all. But obviously, you can stop and ask questions if you need to at any point.
Okay.
So we're looking at the finance unit, and this is a review for the finance unit. And you can see on the screen that the things that we've done are simple and compound interest. We've done annuities and we've done mortgages. We also did budgets, but I'm probably not going to put budgets on the test. I'm probably going to leave that out. If I decide to put it in, I will definitely let you know ahead of time. But these are the three main areas that we covered, and all of these will definitely be on the test. Okay, so let's start by reviewing a couple of the formulas that we've used in this unit. On the screen, you can see I equals PRT. That's a simple interest formula. If all I want to know is the interest, that's the formula that I'm going to use. Then I have A equals P1 plus RT, and this is another simple interest formula. But this is the formula you use when you want to find the amount. Now remember that amount is the interest and principal added together. So if all you want is the interest, use the first formula. If you want to know what the total is, including the interest and the principal, use the second formula. So those are the two simple interest formulas. Then we did a compound interest formula. And this is the formula for the compound interest, which includes the principal, the interest. Now, that interest rate sometimes has to be adjusted, and the n is the number of compounding periods, and that has to be adjusted sometimes again. That depends on the compounding frequency. And we talked about different compounding frequencies. We talked about quarterly, we talked about semi-annually, we talked about monthly, and even daily and weekly. All of these came up in various questions, and you're going to have to know those things in order to be able to adjust the I and the N. Then we looked at annuities, and there are two annuity formulas. And the first one has to do with the amount again. And this is the amount in the future. So you're there putting in money into an account, and that's what the R represents in this particular formula. You're putting money into an account at regular intervals over a certain amount of time. And what this formula does is tells you how much you're going to have in the account in the future based on the interest rate and the length of time that you've been putting all this money in. And that's what this annuity formula does. The second annuity formula tells a different story. What it tells you is how much I have to put in each time to get to an amount in the future. So the question gives you the amount in the future, and you have to figure out how much you have to put in each month or each quarter to get to the amount in the future. So sometimes when you're looking at these questions, which are annuities, you have to ask yourself if the amount that they're giving you is a regular amount that you're putting into the account, or is it the amount that you want to have in the future? Because that's the clue to figuring out which of these formulas you're going to use. So these two are the annuity formulas. That's your compound interest formula. That's your simple interest formulas. And there are two versions of it. Let's keep going. Now, hopefully you can read the question on the screen and make it a little bigger for you. And I'm not going to do the question, but I want you to read that question for yourself. And I have all the formulas at the top of the page, the two simple interest formulas, the compound interest formulas, and the two annuity formulas right here. Which one of these, look at the question, calculate simple interest earned for the following investment, $7,600 invested for 8 years at 12.25% per year. Which one of these do you think would best work out the answer for this one? Is it the first one, the second one, the third one, the fourth one? Which one of them do you think would be the best one for this one? I'm waiting
I
to hear from.
equals I equals PRT.
So that's exactly what I'm going to put that one right there. That's the one we need to use for that question. Okay? Again,
Okay.
I'm not doing the question. You have to do that for yourself later on online and work that out. Let me continue. Let's read this question. Find the amount of the following investment. $75,000 invested for 20 years at 3.4% compounded semi-annually. Again, it's one of these 5 equations on the top. Which of these 5 equations do you think this one would work best with? Read the question. I'll make it bigger for you. And you tell me which is the best equation to work this one out. What do you think?
A equals P 1 bracket 1 plus I bracket N.
So you're talking about this one right here.
Yeah.
Perfect. The compound interest formula. And the clue to that one was the fact that it says compounded. So it can't be either the simple interest formulas because it says compounded. So we can't use the simple interest formula. And that's why I'm pulling this one down here. So
Right.
again, I'm not going to do the question now. You're going to do this online later on. I'm going to
Right.
continue. Question 3. Determine the accumulated amount of the following simple interest investment: $4,500 invested for 3 years at 2.8% per year. Which of these formulas do you think would best work out this?
A equals P bracket 1 plus RT bracket.
Perfect. So let's pull that one down. Again, work that out for yourself later on. That's perfect. And the reason why this is the best of formulas is because it does say simple interest. It's actually one of the simple interest formulas, but it doesn't just want you to get the interest. It wants the interest and the principal together. That's why it says accumulated amount. So we need both of them in the answer, and that's why that is the best formula for that question. Let's move on. Find the final amount of the following investment: $780 every month, invested for 10 years at 3.4% per year, compounded monthly. Look at your formulas above and you tell me which would be the best one for this question. I probably should have put numbers beside them or letters beside them, but just, give me an idea of which one of them you think it is. This call is number 1, call is 2, call is 3, call is 4, call is 5.
Okay.
Which one of them do you think? Which one of them do you think would be the best suited to calculating this answer?
Number 3.
So you're talking about this one here, A equals P1 plus I to the power of N.
Yeah.
Here's a problem. This one is just a regular compound interest formula, but this is an annuity question. Once you see where it says, find the final amount every month, you're putting $780 every month into the account. So that's an annuity. Whenever you see that you're doing something regularly, like every month, you're putting in the same amount every single month, that makes it an annuity. And that's why just a regular compound interest formula wouldn't work. So it's either this one or this one. Let's narrow it down. So it's not one of the first 3. It's not these 3.
Okay.
It's either this one or this one. So which of those 2 do you think makes more sense for this question?
Number 4.
Number 4. Absolutely correct, because you have the regular amount. That's the $780. So what you're really trying to find is what is the amount, and that's why it's A equals. So you need to put that 780 as your R, figure out what your I is, figure out what your N is, and complete that question. Okay?
Okay.
Let's keep going. What is the payment if you want $120,000 in 20 years at 4.2% compounded monthly? Again, let's call this equation 1, 2, 3, 4, and 5. Which of these do you think makes the most sense in this case? Read it for yourself and then you tell me. What is the payment if you want $120,000 in 20 years at 4.2% per year compounded monthly?
Number 3.
Number 3.
Yeah.
Okay, is this an annuity?
No.
It is. It is. No, it is. When you see payment, it almost definitely is an annuity, because what you're doing is you're putting in a certain amount of money every month for 20 years, so that at the end of 20 years, you're going to have $120,000. Okay? So this is an annuity. So the question now is it the first or the second annuity? So you're right that it is a compound interest question, but it's not the simple compound interest formula. It's an annuity because you're doing a regular payment. Every month you're putting a certain amount in to be able to get to a certain amount in the future. At some point, I hope you're going to watch the video that I sent you, because that, I think, is going to help you to figure out annuities a little better. Okay?
Right.
All right. So tell me now, equation 4 or equation 5? I want to get to
Equa
100. Go ahead.
equation 4.
Okay, let's look at equation 4. What is the payment? Equation 4 tells us the amount that you'd have if you put a certain payment in. So that was like what we had on the last question, but this one is different because this one says you know what your amount is. Your amount is $120,000. So what you're trying to figure out is, what do I put in every month to get to that $120,000? And that's what this R represents. And that's why it's actually equation 5. Okay, because I have 120,000. I want 120,000. That's what I want to have in the account. That's my A, right?
Right.
And I'm going to be trying to figure out, what do I put into the account? That's what I'm trying to do. I'm trying to save up enough to get to that $120,000 in 20 years. So this R here, when I work it out, will be the amount I have to put into the account every single month. This is a monthly thing, to get to $120,000 in the future. And that's why equation 5 makes the most sense in this case. Okay?
Right. Mr.
All right, let me
Kama,
go on. Yes, go ahead.
I was gonna say, if A stands for amount, what does R
Yeah.
stand for?
The regular payment. What is the amount that you, you know, like how an annuity means that you're doing a payment every month or every quarter, every 6 months or whatever. That's what the
Right.
R is. What is that? What is that regular payment that you're making into the account? All right. So that's what the R is. In this case, I don't know what the R is. I mean, you'd have to work it out. But when you work out that R, if you want to have $120,000 in 20 years, every month you go to the bank with that R at 4.2%, and you'll have the $120,000 in 20 years. That's what this is trying to work out for you. Okay.
Right.
Let me take you back to the previous question just for you to see what's the difference. This says, what's the final amount of the following investment? $780 every month. This is telling you that you're putting in $780 every month, and you're trying
Right.
to figure out what that is going to become at the end of, 10 years. There's the difference. So this one is giving you what the R is, and you have to figure out what the A is. This one is giving you what the A is, and you have to figure out what the R is. You see the difference?
Right.
Okay, so let's move on. Okay, now let's read this question. And this is going to really test whether you are sort of comfortable with this whole concept. Mark will need to replace his tractor in 3 years. So Mark knows that his tractor is going to last him for 3 years. A new tractor is going to cost him $90,000 at that time. So in 3 years, it's going to cost him $90,000.
Okay.
How much should he invest every month at 9% per annum compounded monthly to have enough money to buy the tractor? Okay. How
Okay.
much does he invest each month at 9% per annum compounded month to have enough money to buy the tractor? So think about that and think of which equation on top here. Again, it's 1, 2, 3, 4, or 5. Which of those do you think might be the best candidate for this question? Let's do this before you answer. Is this an annuity question or not? What do you think?
Yes, it is.
Perfect. So that's a good answer. Because it's an annuity, we now have to ask ourselves, do we know the amount in the future that we need, or are we trying to figure out what amount, or are we trying to, okay, there are one of two things. If it's an annuity, which you agree with, and I agree with you, by the way, what does the 90,000 represent? Does it represent the amount in the future, or does it represent what you're trying to put in every month in order to get to an amount in the future? What does the $90,000 represent to you in this question?
Amount in the future?
Perfect. So now that we've narrowed it down, try to see if you can use that to figure out whether it's the A equals or the R equals in this question, in this case. So see the equation 4 or 5. Which one do you think?
Equation 4?
Well, here's the thing. Equation 4 is asking you to figure out the A, which is the amount. We have the amount. The amount is $90,000. What we don't know is the R. And that's why we should be looking at number 5. Because the A is, so we're going to put the A as $90,000 in the question. And then we're going to figure out what that regular payment is that gets us to the $90,000. That's the difference, right? So we're going to use this equation right here, equation 5. The A is going to be the $90,000, right? That's the amount in the future. So the amount in the future is your A. So if you have the amount in the future, you're going to use equation 5 every time, because that's going to know allow you to work out what the regular monthly payment is. Hopefully that makes some sense.
Right.
Okay. All right. So let me move on. So now I'm going to go to the mortgage part of the unit. And so we finish all of the compound and simple interest and annuities section. Now let's get to the mortgage part. This says that Martha is buying a home for $600,000. She has a 20% down payment. She's going to be getting a mortgage from CIBC, that's one of the banks here in Canada, for the rest of the price at a rate of 3.4%. That's the mortgage that she's going to get, 3.4% amortized over 25 years on a 5-year term. Let's answer these questions for Martha. How much is the down payment? I think you're okay with that calculation.
Yeah.
Yeah, okay. So you know I'm going to take the 600,000 multiplied by 20% and get a number from that. So I'm going to, again, leave that to you to do that on your own. Okay?
Okay.
How much is the mortgage now? Well, remember, if $600,000 is the house, you're not borrowing the whole $600,000. The bank is saying that you, or in this case, Martha, has to have some of the money to buy the house. And some of the money in this case is 20%. So on the previous slide, we said that we could find the down payment by taking 600,000 multiplied by 0.2. So whatever that number works out to be, the down payment, I'm going to subtract that from the house price, from the $600,000. And whatever that difference is, when I subtract the down payment from the house price, that's my mortgage. I think you understand that part as well, because I don't think you asked me any questions about that. Does that make sense to you?
Yes.
Okay, perfect. So again, you can finish that up on your own.
Okay.
Now, I'm going to get to this page. What is the monthly payment? Well, I'm going to kind of give away one of the answers. It turns out that the mortgage is for $480,000, because when you take the 20% and you subtract it from the 600,000, it works out to be $480,000.
I think that's what I did wrong.
Right. So let's get the mortgage payment summary now. I went to the website and I copied what they have for. So again, here's the situation. She's buying a house for $600,000. Go back to the slide before. We're going to take out the down payment, which is you can work that out for yourself.
Yeah.
And take it away from the house price, and the rest of it is the mortgage. The mortgage works out before. I'm going to give away that answer now. The mortgage works out before $480,000. Right.
Okay. Right.
So I put that into the calculator. I didn't put 600,000 because she's not borrowing $600,000. Hopefully that's clear. The bank is saying that they're only going to lend you after you take out the down payment. So we take out the down payment, and what's left is $480,000. I put that into the mortgage calculator with a 3.4% amortization. Just give me 1 minute here. I think there's somebody. Okay. All right. Let me go back here. And sorry, you can still see my screen, right?
Yeah.
Okay. So we're at a 25% amortization, and the 3 point, I put all that information into the mortgage calculator website, and here's what came out. Now, tell me where I'm going to look on this summary for the answer to the first question. What's the monthly payment, right? Where is the monthly payment on here? Can you help me with that?
It's right here.
Can you look at? It's right here. You're right. It's right there. 300 payments of this amount right here. All right. Oh, sorry. I just did the wrong thing. I clicked the wrong button. Sorry. Yeah. So hopefully everybody can see that this represents the monthly payment. Everybody clear on that, hopefully.
Yeah.
All right. I'm going to move on. So the other question they're asking, same question again, is still Martha buying the $600,000 house, put the 20% down payment, all the stuff we just talked about. It says oh, I went too far ahead. Sorry. Oh, geez. Oh, no, sorry. I didn't go too far ahead. What's the monthly payment? Here we go. D, at the end of the 5-year term, How much interest will she have paid? No, it's the same. I didn't change anything. Same mortgage summary. We're now answering a different question. The first question was, what was the monthly payment? At the end of the 5-year term, remember now that she's paying it over 25 years, but she's breaking it up into smaller time periods. And each time period is called a term. So at the end of the 5-year term, how much interest will she have paid? That answer is sitting right here in this mortgage summary. Can anybody tell me what number in this is the interest that she's paid after 25 years? That's really what we're trying to figure out right now. Interest that she's paid after 25. It's in this, it's somewhere inside of this. All right? Somewhere inside of here is the information. I'm going to give you one clue, right? Since I don't hear anybody yet. Don't look at over the 25-year amortization period, because I'm only asking about the 5-year term. So I want to look at the section that deals with the 5-year term. So somewhere inside here is how much interest she has paid. And it will tell you how much interest. In fact, you know what? I'm not going to give away the answer. I'm going to leave it there. All right? Look at that for yourself, and you try to figure out how much interest she has paid. Is that a reasonable thing? Let me just admit to that here. All right. Okay, so I'm going to come back, and I'm going to ask you to finish that question. I'm going to move on to the next one. All right, look again. Let me just tell you, I haven't given it an answer. I'm telling you that somewhere under where it says over the 5-year term, you will. Somewhere inside here is the answer to how much interest you will have paid at the end of the 5 years. Somewhere in there is that answer. I'll move on to the next question. I'm not giving anything away. You have to do this for yourself when I put this online later. This question says, how much will she still owe? In other words, after the 5 years is up at the end of the term, how much does she still owe? So I'm saying this to you again. Do not look up here under the 25-year part. Don't look up there. Look down here over the part that says over the 5-year term, right? Somewhere down here, it will tell you how much she still has left. In fact, I'll just give you one more clue. I'm gonna give it away, right? In fact, can anybody tell me what the answer is? Looking at the screen, can anybody tell me what the answer is? How much does she still owe? She hasn't paid off the mortgage yet, because the mortgage has to be paid off over 25 years. She's only paid for 5 years. So, go ahead.
Sorry,
I'm listening.
sorry. I'm just looking at it again.
Yep.
So, where it says you have a balance of 413,000, like that.
Correct. Ding, ding, ding. Give him the points. He got it right. That's exactly right. It tells you that you still haven't. This is the amount you borrowed, $480,000. That's the amount you borrowed from the bank, but you still owe $413,000 after 5 years. After 25 years, you'll pay this off, but you've only been in this for 5 years. So it's telling you that after 5 years, this is how much you owe. Okay.
Okay.
So hopefully that answers. I've given away that answer right there. When I put it on, when I get to the online thing later, you can certainly see that for yourself. Okay. I think it's the last question. At the end of the 25 years, so now we're looking first at the 5-year mark. This was a 25-year loan. So what we're saying is that you're actually going to pay it off when you guys get a mortgage later on to buy a house. At some point in time, the expectation is you're going to pay off the bank and you don't owe any more money on the house. So it's now asking at the end of the 25 years, if our interest rate doesn't change, so it's the same interest rate, everything else is the same, how much interest will Martha have paid on this loan? So here's what I'm going to say to you. We're not looking down here over the 5-year term anymore. We're going to look somewhere inside of this box right here for how much interest she's paid, because this is for the whole 25 years now. After 25 years of paying this, somewhere inside here, it tells you how much interest she's paid. Can anybody tell me what that number is? How much interest that she has paid?
She paid $231,000.
Perfect. So she's paid back the $480,000 because that's what she borrowed. But on top of that, this is the interest that she paid on the loan. This $711,000, that's when you combine the interest and the principal together, right? That's where this number here comes from, by adding these two numbers together. But the fact is that she paid back what she borrowed, plus she paid interest, which is what the bank is keeping as their profit for doing business with Martha. So that's 28 minutes into the class, and I've answered all the questions that we had for this. I'm not going to keep you guys long unless you have any questions, because I don't have any more slides on, or do I? Let me just double check here. I think that was the last one. I don't have any more slides on this. I'm going to go back through each of the slides again, right? Just for us to make sure, for those who joined late, that everybody's on the same page. So I'm going to announce again, for those who weren't here, that this is a review class and that we're going to have a test on finance in a week from now. So next week, Tuesday, I have a whole week to get ready for this. The test is going to be based on the things that we did in this unit: simple and compound interest, annuities, and mortgages. I probably won't put budgets on here. I know we did budgets as one of the classes, but I'm probably going to leave that out. And we won't have a class on Thursday because I'm expecting you're going to use that time to get ready for the test. And that all these questions that we have on this review, I'm going to put them on an online quiz that you can use to kind of prepare for the test. So we didn't work any answers out today. So I'm going to quickly go through all the questions that we did, and then we're done. So I was asking, first of all, I was going over all the formulas that we had. When you're doing the test, you're allowed to have a formula sheet, so that's fine. So the simple interest formula for just interest only is this. The simple interest formula for amount is that. The compound interest formula is this. There are two annuity formulas depending on what you're trying to work out. And then what I did is I went through a couple of questions and asked which formula out of the ones above. And for this first question, it was just simple interest. It was this one. That's why this formula is drawn down here. The formula was up here, and I brought it down here to show that that's the right one. In this case, the question was a compound interest question. So this is the formula you're going to use for that, but it's not an annuity, right? This one was a simple interest question, but it's not just the interest. It's the interest and the principal. It's the amount. So that means that this is the formula we're going to use for that. Then this one turned out to be an annuity question. And the reason I say it was annuity because you're putting a certain amount into the account every month. So the R in this case is the $780. And you're trying to figure out how much I'm going to have in the future based on that. And then this one was another annuity question. But now we know the amount we have in the future. What we're trying to figure out is what is among the payment. That's what the R is. R is a regular payment. We know the $120,000. That's going to be your A. Then this question was another question similar to the last one, where you have your amount in the future, $90,000, and you're trying to figure out, what do I put into the account every month to get to that $90,000, given this interest rate, given this amount of time. Then we got to mortgages, and we went over down payments, because this house was for $600,000 with a $20,000 down payment, and that's just multiplying 0.2 by 600,000. That will give you the down payment. And then we take away the down payment from the house price, see what the mortgage is. How much is the mortgage? Well, just subtract those two numbers. And then we started looking at the figures from the website. Monthly payment based on the mortgage amount, which is not the house price. The house price is not the mortgage amount. It's $480,000 in this case. And this thing I circled here would represent the monthly payment. Then I looked at how much interest she would have paid after 5 years. So don't focus on the 25-year part of the mortgage summary. Focus on the 5-year part. And again, I'm not going to give away the answer. Somewhere under here, it tells you what the interest is that she paid. How much does she still owe? Well, one of you actually nailed it. You just simply look down here. What is the balance after 5 years? You still owe this amount. You borrowed $480. You still have this amount that you have to pay. Then I looked at the end of the 25 years. So let's come up here now and ask how much interest she's paid. So look in the 25-year, over the whole life of the loan, how much interest have you paid? Is this number right here. And that's it, folks. I'm going to stop sharing at this point. That was the last slide. Yeah, that was the last slide. All right. So let me just remind you, there is no class on Thursday. The next time you are going to be doing anything will be well, you're going to be working to get ready for the test. And I am going to put an online review with the same questions we just had, right? I haven't worked, we didn't get any of the answers here, but I told you which formula to use. So you're going to work on getting the formulas, use the formulas to get your actual answer, put it in and see how well you do. So unless anybody has any questions,
Wait,
I'm going to
Mr.
leave it.
Kamak,
Yes, sir.
You know, for the test, math test next Tuesday,
Yes.
will it be just like the review?
It'll be similar to the review, but I'm going to obviously change up the numbers.
Okay.
All right. The review that I'm going to put will have the same numbers from today. And of course, we haven't worked out the answers yet, but you're going to work them out for yourself. But then the test will have similar questions, but obviously I'm going to change up the numbers. Okay?
Yeah.
All right.
Okay.
Anything else?
Nope.
All right. All right, folks. I'll leave it there. We will be in touch again on Tuesday of next week when we're working on the test. All right?
All right.
All right, later. Goodbye.